Okay, let's start. So yesterday we have discussed BoxPlot, fine, and then we have also seen an example, fine. So if you see, mm, okay, yeah. So we have seen the example like how to find out. So just to give you a recap, uh, how BoxPlot will help us to detect the outliers, guys. It will find out it will draw a plot, fine, and it will calculate the lower bound and upper bound values, fine, from this formula q1 minus 1.5 into iqr, where iqr is the interquartile range, which is just the third quartile minus the first quartile. Okay, and using this we can find out lower bound and upper bound. Now the point is, any value less than lower bound will be an outlier. Similarly, any value greater than upper bound can also be outlier. Fine. So one important point yesterday I have mentioned is all the values which are seeing over here, q1, q2, q3, right, and mainly this lower bound and upper bound, these values need not be actually present in the given data set. Agree? Actually need not be present in the given data set. Fine. There might sometimes there might be in the decimals. Right. If you have 50, the q1 might be 50.5. So yesterday also we have seen an example. Yeah. So we have seen an example that the lower bound was like 7.5 and upper bound was 19.5. But if you see in the data, there were no data, no points with 7.5 or 19.5. Fine. But still 7.5 is a lower bound and 19.5 is upper bound, because those are the values which the formula decides. Fine. So till 7.5 it will be considered as a perfect number, not an outlier, and also till 19.5 that will be considered as an not an outlier. Fine. So this is how we have seen, and yeah, we also seen how box plot will clearly help us to visualize and also understand instantly what are the outliers. Fine. So here any value above this line, this whisker is there, right? Any value above this line and any value below this line will be represented in the form of dots. Okay, and those will be outliers. Fine. Now let me yeah, so let me see. Fine. So now first we'll see few examples from the data frame how you can plot in box plot. Okay. Hmm, are you there, guys?
Yeah, Santosh.
Okay. So if we take an example, so let's say I'm having this auto mpg data frame, right? So if I just plot, sorry, okay, and this is my data set. Now, if I can directly just, this is empty cars is my data set. In this, these are my columns. Fine. I can directly take one column. How to take one column is empty cars. Okay, and this is the way how you can access a column. Fine. This is a pandas function, which we'll be seeing in the pandas class. But as of now, just remember, when you give data set and square bracket open and close, inside that if you give the column name, that means you're accessing a single column. Okay. After that, dot plot. Okay. Inside plot, kind equal to box plot. If you remember, we have seen in the similar way to draw kind equal to histogram and bar graph. Correct. So here the kind will be box. So now if you do that, okay, see here what it is saying. See, I also don't know how this empty cast mpg looks like, guys. Fine. See, I've just downloaded this, but okay, so I've just uh, loaded this into the notebook, in the notebook, but I did not analyze this column. Okay, I don't want to analyze also. Okay, I don't want to analyze also. Fine. So just it has accessed this column, and it is giving me this diagram. When I say box plot, it is giving me. But just by looking this, just by looking this as a new person, what all we can infer, we'll try to understand. Okay. So it is saying, first of all, it is saying that the minimum value could be somewhat around 10. Okay, not exactly 10, but looks like something just less than 10. Okay, around 9. Okay, what is this? See guys, try to understand this important point. If at all you don't see these dots, what are these dots, guys? Circles, bubbles, outliers. Fine. So if at all you don't see any outliers, the whisker will be the this whisker will be the maximum value, in the given data set, maximum value from data set. Okay, if at all this is not present, fine. Ultimately this graph will plot all the values from the given data set. Okay, ultimately this graph will plot all the values from the given data set. Okay, see, I will first I'll take this example. You'll understand better. Okay, see, this data set is having these three outliers, 1 or 2, 7, 8. That is the reason what it is doing, it will plot each and every data from the given data set, but the way how it is plotting will be different. What all the data which it is not which it has not considered as outliers, those will be plotted with as a box plot, and the values which you treat, which it has considered as outlier, those will be plotted as these bubbles. Okay, dots. Fine. So now if you see, what you can try to understand over here is, in the given data set, the minimum value is 10. Okay, minimum value is 10, maximum value is 108. Okay, just ignore whether it is an outlier or not, but just from the given data set, minimum value is 10, maximum value is 108. Agree? So here also if you see, okay, let me write here 10, 108. So if at all there is no, in the lower side, okay, if at all there is no 10, 108, okay, these are the outliers. Okay, yeah, in the lower side, if at all there are no outliers, you cannot see any bubbles over here, right? So that means what, this whisker, whatever you are seeing, okay, this should represent the minimum value from the data set. Fine, minimum value from the data set, that should be 10. Agree? But in the upper side, if at all these outliers are not present, obviously this whisker will be the maximum value from the given data set. Agree? But if at all there are outliers, then this will not be the maximum value, because above this there are some outliers. Those are the maximum values from the given data set, but those are outliers. Okay, so those will also be plotted. Fine, those box plot will not leave those. It will also show those, but those will not be considered in this plot. Fine. So the maximum, if at all you are having an outliers, obviously it is clear that this whisker, what we are seeing, that is not the maximum. This is not the maximum value from the data set. Why? There are some other maximum values above this, which are this. This will be the maximum value. Agree? But this is an outlier. That's fine. But you should not consider this whisker as the maximum value. This is just the maximum value excluding outliers. Agree? So from the given data set, I have 10, 108. So what I'm trying to convey over here is, so if I see 10, okay, minimum value is 10 from the given data set. So from the lower side, this side, the minimum side, there are no outliers. Fine. So obviously it is starting with 10. Fine. There are no outliers plotted. So it should start with 10. So the whisker, what we are seeing, that should be the starting value. That should be 10. Fine. That should be the 10. Agree? But the upper side, okay, but the upper side, whatever you are seeing, fine. So it is, there are some few outliers, fine. So it is starting with what? The maximum value over here is 108. Fine. So this whisker should not be the maximum value. Fine. So now if I come back over here, okay, if I try to see here, see, what we are having over here. So just by looking at this, I can understand that, okay, there is some minimum value. Okay, there is Q1. Okay, this is Q1. Okay, this is Q2. Okay, this is Q3. This is Q4. Fine. So now it is saying that I can understand there is only one outlier. Okay, and it is somewhere median is something around what 23 sort of thing, correct? That means 50 percentage values will be less than this. Okay, and also if you see this, the length of the whisker also matters, guys. The length of the whisker will also give you some information. Fine. See, see, from minimum value, okay, this is the minimum value, this is the lower bound. Fine, lower bound, that means minimum value. Fine. So it is saying the density, that means the values are closely packed, the values are closely packed from the minimum value. Fine, from the minimum value till the median. Okay, this is median, right? Q2 is median, Q2 is median. If you see, if you see this length, guys, from, yeah, this length from median till this lower bound, this length is shorter than, okay, is shorter than this length, right? Again, from median to Q4, this maximum value. So the density over here is higher than here. That means what? The values are closely packed here than here. Okay. So here you can see a little larger length. Fine. And it is saying that there is a one outlier. Okay. So these are basic inferences which we can make out. So now we'll go and see this. So if at all, if I go here, okay, if I fine, I'll take this MPG column, okay, and I will paste here, okay. And if you see, okay, and this is not in the sorted order, so I will go here, do smallest to largest. Okay, now this is sorted order. Fine. So initially, first observation is minimum value is around 9. Okay, minimum value is around 9. Fine. So this also looks like around 9. Okay, this also looks like around 9. Fine. So but if you want to find out, you can also do this. What will be the minimum percentile? What should be the lower bound? Okay, we need to calculate, right? So for the lower bound, what we want is Q1. We need to find out Q1. Agree. And we need to have Q3, Q1, Q3. Fine. And here my values will be percentile 25th and percentile 75th are my Q1 and Q3. Agree. Now if I print, oh sorry, 25th percentile and 25th percentile. Okay, so my 25th percentile is, it is saying 70.5, and 29th percentile is, sorry, 75th percentile is 29. Okay, so just to I want to check 50th percentile. Okay, let me see. Oh, here I need to do only what I can do is just take this. Okay, 50th percentile is, it is saying is 23. Agree, guys? 23 it is saying. That means what? 50% of the values will be less than this number 23 and above is 23. Okay, now if I go to this one and if I see how many values are there total, 399. Can you see it? Can you see 399? This value, can you see this once confirm? It is small, right? So can you see this? Huh?
Santosh had out.
Hmm.
Uh, so before plotting, do we need to sort the data, or automatically will it take?
Automatically will it take, man. For plotting, you don't need to do anything.
Okay.
Yeah. Now, can you see this 399 number?
Yes, Santosh.
Okay. So Overall, you are having 399. Okay, roughly, let's say 400 values it is having. So where should be the median? Where should be the median, guys? 400 means 200.
200, 200
Okay.
and one, two.
So if you see around 200, you are having 23. Agree? The same 23 you can see over here. Fine. So that means percentile, 50th percentile, which is also median, is the 23. That means that is cutting the data into half, two parts. Fine. So now this is one part. Now coming to second part, if you want to see the 25th percentile, 75th percentile, so these are my 17.5 and 29.5, 29.0. Fine. So now what will be this value? This value will be the lower bound. And what is the formula for lower bound? Lower bound equal to Q1, okay, Q1 or 20, P25 minus, fine, 1.5 into IQR. What is IQR, guys? P75 minus P25. Getting? And my upper bound is what? Upper bound is 75th percentile. That means Q3 plus, okay, 1.5 into IQR. IQR is just Q3 minus Q1 or 75th percentile minus 25th percentile. Getting? So print LB, comma UB. Fine. See, what is my lower bound? Lower bound is 0.25 and upper bound is 46.25. Okay. So it should plot, yeah, it should actually plot 0.25 over here. So what is this value? It is ranging from 9, right? So what mistake did we do? Let me just check. NPD percentile. Okay, quantile I minus. Oh, quantile I. Okay, I think PA minus 1.5 into this. Okay, PA plus 1.5 into this. So still the same. That should not be the value. Fine, let me check this. Okay, if I put the values over here, let me do this. Okay, then we are printing IQR, right? And then we are this, right? And then we are printing lower bound and upper bound. Okay, so now if I take this, if I go over here, fine, and then to this displacement value, if I put it over here, okay, and what I want passing, I am passing in the place of data set this, okay, 25th percentile, 50th percentile, printing quantile 1 3, IQR Q3 minus Q1, print IQR, quantile 1 minus 1.5 into IQR, okay. Yeah, okay, lower bound it is giving us minus 0.25, sorry, 0.25, 46.25. Okay, does this looks like 0.25 as a lower bound? Okay, no, the lower bound is, um, 1 second, guys. The lower bound is actually what, Q1 minus 1.5 to IQR. Okay, so this is the uh, minimum value. Okay, this is the minimum value which we are getting. Fine. So it should also plot. Okay, it should also plot. I'm just no, I'm just thinking about whether this could be 0.25. Okay, whatever you are having this bar, right? So because we don't have the clear graph over here, so I'm just thinking if this is 0, right, if this is 10, whether whatever we are having over here, will this be 25 or not? Okay, I'm just thinking that. Fine. Okay, so if you're having small dot over here, I will check that and get back, guys, because it might be 0.25, but I'm just having a doubt whether this could be 0.25 because it is somewhere over here. Okay, but anyhow, fine. See, now if you see here, the upper bound is 46.25. Okay, somewhere over here. Okay, so and it is saying one what is this outlier? Okay, one outlier. So from the data set, if you go here, okay, and if you see what is the upper bound, guys? Upper bound is 46.25. Okay, and if you see what are the values greater than 46.25, how many values are there here greater than 46.25?
One value.
Right? So that's why you can see this one dot over here. Agree? Is this clear, guys? Okay, so that's how you can plot using the dot plot box. Okay, so simple. But you don't need to do all this. I've just shown you to do all this. But see, you can just you can also, what you can do is you don't need actually need to do all this. Okay, so just what any other, so let me take what displacement. Should we take displacement? Take displacement, go over here, plot it. That's it. Okay, there are no outliers for displacement. Okay, and for cylinder, if you go and take it, fine. See here, the value, like whatever you're plotting, right? So here it is not having the uh, Q3 part. Okay, what all the values it is having. So the maximum value itself is 8. Because if you see the um, cylinder, see what does cylinder value look like? If you see cylinder value, if you see, so yeah, it's only, okay, it's only 4 6. Okay, if you see the unique values of the cylinder, yeah, there are only 5 unique values, right? 3 4 5 6 8. Okay, so maximum value is what? Maximum value is 8. Okay, maximum value is 8. So it is not having any like Q4 or the upper bound. Okay, so but if you take some, let me take horsepower. How does it look like? Okay. Mm, no numeric data. Oh, horsepower. I think the data type of horsepower is different. Even though it is showing here, it might be different. Fine. So now, fine. I will show you one more thing about MPG. Okay. So here using MPG, you are able to see this, right? Now what I will do. Okay. Now what I will do. I will add. Okay. I will add one more value. Okay. Let me add. Okay. I'll repeat all these values. Okay. I'll repeat all these values. Fine. But I will add. Let me say 47 also. Fine. So if I save it. And if I save it, if I go here, if I load it, okay, and if I plot it, see, can you see two dots here now?
Yes.
Okay, so that you got two outliers. Getting? So you can directly see it on the data frames. Okay, so you can add like 48, it will show three outliers. Okay, like that. Fine. So that is how you can draw using the basic plot diagram. Okay, I would say from the data frame itself. Okay, using matplotlib. Fine. So, but you can also draw box plot using a seaborn, guys. See, seaborn, as I said, there are mainly you will have matplotlib, okay, for visualizations. Okay, in ML, okay, in data science you have matplotlib, and then you have something called a seaborn. Seaborn. Okay, Seaborn is more advanced than Matplotlib. Matplotlib is for basic graphs like histogram, bar gram, like that. But Seaborn will give very good and advanced visualizations. Okay, very different visualizations you can make. Apart from this, there are other also, you call it as something like ggplot. You have like bokeh. Okay, so there are like actually a lot of uh, packages available for the visualizations. Okay, but all these are not important, at least in the initial stage. Okay, mainly you should know graphs to draw from matplotlib and also from seaborn. Okay, however, don't worry, we'll learn once this is done, right? Next we are going to study numpy, next pandas. Okay, next you have visualizations, matplotlib and seaborn. Over there we will see these different types of graphs. Okay, but as of now, just see how to draw box plot using Seaborn. Simple. From import Seaborn as SNS. Okay. Usually we import Seaborn as SNS. You remember we are importing NumPy as how NP, Pandas as PD. Okay. Seaborn as SNS. Okay. Usual imports. So SNS dot box plot. Okay. Directly this Seaborn has direct inbuilt graphs. Okay. Box plot and give the data frame. Okay. So here if I want to, okay, or if I do this, see, I'm giving just the data frame, so it is drawing the all box plots for every column, mpg, cylinder, displacement. Okay, but at the same scale, because it should maintain the same scale, right? So that's why it is giving you all columns. Okay, from this if you can just understand, it is, we can understand that which is a column which is having the maximum value, it is the weight column. Okay, its range is very much high. It is starting somewhere around 1500 and going all the way till 5000, but all other are very very small, very small. Getting is, with single graph you can get an idea of all the columns, what type of columns you are dealing with. Okay, so if you see the weight column, it is having around 5000. Okay, where yeah, so I think this column, yeah, this column, if you see, its range is very high, right, in thousands, but these are in tens, single digit, hundreds, just hundreds, but this value is high. So its box plot will also be little higher in the graph. Okay, but if you want to go for only one, if you want to go for only one column, you can also do that. Okay, see, this is much more beautiful than the simple graph, right? See, it is also, the representation is much better. Fine, so these two bubbles are the two outliers. Agree, guys? Okay, and yeah, so this is how you can plot the box plot. Okay, and also for displacement, if I want to check, okay, yeah, displacement also looks cool. If I go for the weight, okay, weight also looks decent. Okay, and acceleration. Acceleration, there are 1, 2, 3, 4, 5, 6. You say lower lower side also we are having 1, 2, 3, 4, 6 outliers it is having. Clear, guys? Now can will you be able to like plot and understand box plots manually? Yesterday we did manually, you remember? So if you want to do manually, it's your wish. Okay, just for your understanding, take a data set, sort the data set. Okay, calculate q1 q3, calculate iqr, calculate this formula lower bound upper bound, and do this simple function, so it will filter out all the outliers. Okay, manually you can do this. Okay, directly with the plot also you can do two ways. One is directly from the data frame dot plot kind equal to plot box, or with Seaborn for better color codings, etc. You can also go with this box plot. Clear, guys? Let me know. Are we good with plotting box plots, or any concepts, doubts, clarifications? Please make it very clear to you guys. Let me know if you have even small doubt also.
For me, it's clear, Santosh.
Okay, fine. So now we have seen the box plot, right? So this is one more, just one more example, guys. So if you see here, so we have this charts, right? So I'll try to give you an overview of this. So if you see that here we are saying brand A, there is one column brand A, brand B, and brand C. Fine, three columns. Fine. So for A, this is a graph. Fine. Just from the graph, okay, just from the graph, what all you can understand? See, almost the minimum value or the lower bound is slightly less than the 400. Getting, guys? Slightly less than the 400. Okay, 380. Fine. And first of all, the main thing your focus should go on the outliers. There are no outliers. Okay, there are no outliers in this graph. Agree? But the only thing is the maximum value is a bit far from the Q3. Okay, as you can see, it will also tell you the distribution of the data sets, right? Are you able to understand? It will also tell you how what is the spread of the data set, guys. If you see, initially there are values very closely packed. Okay, see 300, 400, 500, 600. Okay, again 500. Okay, 700. Okay, initially they are closely packed. After that, if you see, it went from what? From 7, 8, 9, and then it directly went to 1000, and then it went to 1500. Fine. So at least from here, the values are a bit closely packed. Fine. So, but after Q3, okay, there is a sudden jump and it went till from some 1560. Fine. I think you can also get an idea of the distribution. Idea of the distribution. For example, if you see the other graph in the part 2, okay, just by looking this graph, you can see all values are closely packed. There is no sudden jump. Fine. So that means the q, its minimum value, the lower bound q1, sorry, q0, the sorry, the lower bound, the q1, q2, q3, and the maximum value. Fine. The minimum value, maximum value, all these are like closely packed. Fine. They are closely packed. Okay, there is no any jumps. Fine. But the only issue is this one, we are having an outlier. Okay, and as you can see from just by seeing also, you can clearly make out that okay, all values are nearby each other, but only this 1850 looks like a black sheep. Getting? So that's why it has put it over here above 1815. Okay, apart from that, if you ignore this, if you remove this number, all of them are pretty close. Okay, that's why the graph is very uh, closely packed. You can see how closely packed it is. Agree? But and just one outlier. Fine. But if you go for the, but if you go for the this graph, fine, here also there are no outliers. Fine, here also there are no outliers. But here, even the what? Even the what is this? The minimum value is also not that closely packed. Okay, bit far, and also the maximum value is also bit far. But there are no outliers. Okay, getting guys? That means this graph I can visualize it as, see, this is closely, if at all, see, if at all, if I take this as a median, okay, if I take this as a median, okay, we can visualize this graph, the first graph, as till median it is almost closely packed, right? It is closely packed. Okay, after median it has become slightly this, like this. Agree? Till here it is, till this is median, closely packed. After median, you can see the length is getting increased. Fine, this is A. Now for the B, okay, it is still median also, it is closely packed. So I could say till median somewhat like this packed, and after median also it is almost closely packed. Okay, the whole graph itself is closely packed. Getting? But for C, okay, till median also it is not that closely packed, and after median also it's not that closely packed. Fine. At least we can visualize some distribution of the shape and distribution of the data set, right? Just by looking at the graph. Okay, this we will do when you don't have this data. Assume you don't have this data. Okay, nobody has given you data, just they have given you this graph. Just by looking this graph, you can get an like a small cinema in your mind. Fine. So okay, here the value is starting from here, and so many values are packed till the median, and after median there is a slightly spread. Okay, the spread is increasing. Agree? But here also in third graph, if you see till median, the values are closely packed. But after median, if you see, the length is increasing. That means the values are becoming far away from each other. That means the spread is increasing. Okay, and it has increased till this one. Okay, till here. Fine. So that's why, because if you see, we are having 400. After that, there is no 500. There is no 600. There is directly 700, 800, 900. And after 9, 10. After 10, directly 14. Sorry, 13, 14, 17. Okay. See, 10, 13, 14, 17. So it is increasing 200 to 50. So that's why you can see this stretch, this spread in the data. Okay. Just by looking at this diagram. Fine. So that one point you can understand with outliers. And also, you can also compare between different graphs, guys. Okay, you can also compare between different graphs. How I can do that? See, just by looking at this, I can, what all we can understand, guys. What all we can understand? So we can understand Out of these three, B, the column B is having the most possible minimum value. Okay, most possible minimum value. Agree? Column B. Fine. And also most minimum maximum value. Okay, or smallest maximum value is also column B. See, the maximum value here itself is what? Somewhere around 900. Okay, if you see from the graph also, it is 940. Fine, and it is starting around some 300. Fine, so 300 to 940 is its range. Fine, so if you're dealing with column B, that means clearly you are just dealing with numbers which are ranging between 300 to 900. Fine, so you can do this comparison, and you can clearly see, you can also clearly understand that the what, see this observation, the median of C is greater than what, see, median or Q2. Fine, so what is this, Q2 of C is greater than Q3,
Q2 of
no, Q3 of B, sorry, not Q1, this, what is this, Q3. Fine, this line, this is a median, agree?
yes, sir, got it.
Yeah, this is median, that means Q2 of C, this is A, this is B, this is C. So Q2 of C is greater than, what is this line, stop line, Q3
Yes,
of B. Okay, that means what, median of C column, okay, median of C column is greater than 75th percentile of B column. Okay, that means what, 50 percentage of values. Okay, what does this mean, guys? Median is greater than, this means what, if Q2 is the median, okay, if this is a median, above this how many values will be there, 50 percentage of the C values will be
50%.
there. 50 percentage of C values will be above this line because this is a median. And if this value is greater than I'm saying Q3 of B, okay, that means what, 50 percentage of the values are automatically greater than 75th percentile value of B. Okay, that means its range is clearly higher than these values, the B values. Agree? The Q3 is standing at the level of its Q2. Fine. So obviously this is greater than, the range will be of C will be greater than B. Fine. And also you can say that Q3 and sorry, Q3 of A and Q3 of B, that means median of A and median of B are almost same. Okay, are almost same, the median part. Fine. So like this, you can make different types of observations. Okay, from the given data set.
Yes, sir.
Okay, fine. So after that, see, there are some few interesting examples. Okay, so if you see here, okay, if you see here, so we are having a plot. Okay, we are having a plot of what, team A and its points. Okay, team A box plot is this, team B, team C. Fine. So but clearly you can see who won the game, guys. Who won this game?
C.
See,
Correct, because the maximum value of C is 30. Right, and most importantly, there are no outliers. Agree, there are no outliers. And team A has scored maximum at just 15. Agree. Fine, and started at very low value. Fine, team B started, the see, the TB minimum value, the team B minimum value itself starting from Q3 of team A. Okay, this is what, this is Q3 of team A, right? Agree. And also if you see, the median is almost matching with the maximum value. Fine, the maximum value of team A. Okay, team A's maximum value is matching with almost same as the team B's median value. That means what, half of the values, from this you can clearly understand half of the values are clearly greater than the maximum value of team A. Fine. That means half people from team B have scored values that are greater than the overall score. Overall score, that means maximum value of A. They have scored. That's why this is clearly greater than team A. Now team C also same scenario. Okay, this is a median team C scenario. Okay, fine. So now that is matching with the maximum value of team B. That means what? Half of the value of team C have scored values greater than the maximum total overall maximum of the team B. Fine. That's why team C is greater. Getting?
Yes, Santosh.
Yeah. And also guys, I'm not sure if you're able to like visualize the internal things also. See this line, everything is actually trying to give us some information. Okay, every line, every length is actually giving information. See, even here this line is there, right? So this is a box. Okay, this is a box. That's fine. But where that line is, let me take another color. Okay, yeah. So in that box, where this black line, okay, where this black line is pointing, right? That is also important. See, it is not always pointing in the middle. Fine, it is not always pointing in the middle. See, over here it is at the, let's say 30%. Over here it is at very close to the this value. That means what? This value is Q1 and the median is, the black line is always a median. Okay, that is a Q2. Fine. So that means Q1 or Q2 are very much closer to each other. Okay, Q1 and Q2 are very much closer to each other. Fine. And the distribution is very much packed till Q2. Okay, so this is the minimum value. This is the minimum value. Okay, this is a minimum value, and this is Q1, this is Q2. So the distribution is very much packed. But after median, there is a spread. After median, slowly the values got spreading till here. Okay, it's not evenly distributed. That's what I'm trying to say. Agree? If this line is perfectly at the middle, if the line is perfectly at the middle, what does it mean? 50, exactly, the distribution is very even. There are no packing of values to either side of the median. Fine. So here you can see somewhat of strict packing of values. That's why the median is getting pushed over here. Okay, and same thing goes to other diagrams also. Fine. So now we will see one more interesting scenario over here. So if you see here, what is this? This is a box plot of the Oscar awards. Okay, Oscar awards for best actor and actress. Okay, for the box plot. Fine. See here, I don't know the data from which this box plot is generated. Okay, so I'm just like a stranger, just like you. I don't know what is this data, the behind the data. Fine, but they have given me this plot. Okay, and if you want to visualize, sorry, if you want to analyze based upon this, so we understood till now different concept of box plot. Agree? So now here, if you see, we are having actor, actress. Okay, this is a plot, box plot. Fine. From actor, but before that, we can understand few things, guys. Okay, we can try to understand this. See, what is the starting age of actor? See, it is around 30. Okay, it is around 30. Fine. But maximum till where he is going? He is going till 75. Even though that is an outlier, but still that is an hero. Okay, don't ignore that guy. He's an outlier. Okay, yesterday I said right, important point. Box plot will give you outliers. Okay, box plot will give you outliers, but that does not mean outliers are useless. Agree? It is your decision. It is your decision how to use those box plots. Whether you want to focus on that box plot and bring out some very unique behavior of the data, like if there are some fraud is happening or some irregular transactions are happening, or if that person is an athlete, okay, or etc. So sometimes box plot can give you very important information which the other data cannot give. It depends upon your requirement. But if your requirement is just to focus on the actual data, you can ignore this. Okay, you can ignore this and you can focus on only this data. Fine. How you can ignore these guys? So yesterday we have in this example, you got this data, right? You got this data 102, 107, 108. Okay, you can simply take these values into a list. Okay, append this into a list and then delete this from this data set. Agree? Append this into a list and delete this from the data set. You can do that, right? You can write a simple code. See, all this code we have written. Okay, you can just write whatever you I write. You can create a list outliers, and then you can start appending outlier dot append I. It will append, and just go here and write a small loop to find out, to take only values which are not present in the outlier. So you will be left with only till 19. These values will be removed. Okay, that is one way how you can remove the outliers also. You can detect and also you can remove this. Clear? So over here also, or here also, so it will tell you the box outliers. So it is your take what to do with the outliers. Okay, and now here it is saying, hey, there is one guy, okay, whose age is like 75. Okay, he's an outlier, but here outlier still he is a great guy, because at age 75 he got the Oscar. Understanding? At that age he got an Oscar award. Fine. So but if you see the age maximum, it is starting at 70. Sorry, 30. Sorry, minimum is 30 and maximum it is stopping at 60. It is common, right? Even in our Tollywood also. Okay, somewhere around people will start 20 to 28. So for example, if you take Vijay Devarkonda, he started at 28 and maximum 60. Rajnikant, okay, some people 60. Agree? Actor, it is like matching with the reality. But if you see the actress, yeah, this is also very practical. So see, it is starting at like 20, just about 21, 22, right? So because nowadays, like even the actors, like for example, if you see the Sri Leela, right, and also what was the other in the Kriti Shetty. So these are like very young actress, right? I think their age will be just around like 21, 21, 22. Fine. So as you can see, this is also matching the reality. But also if you see the maximum age, see, it is not as high as actor. It is stopping at just 45, 50. Okay. I think till here, okay, they'll start here. Okay. Slowly till 20 to 30, I would say this is 30, or till median also. Okay. I would say till 33. Okay, they will have high demand. Okay, usually the actors, after that slowly they will start making what, mother characters. Agree? Slowly after that grandmother characters. Agree? Okay, till like what, 45. For example, if you take the example of Jay Sudha, so right, so clearly she has started as a child actress. Fine, even less than this. Okay, then slowly, okay, her career picked up, and at the age of now she's in the middle. She she did what, heroine character, then she was top heroine. After that she did what, she did mother character. After that at the age of 45, 50, as of now she also done some grandmother characters also. Agree? Fine. So that information, so obviously in general we are able to understand multiple things just by this diagram. What is the minimum age of the actress, what is the maximum age of an actress. Fine. So what is the distribution, etc, etc. And you can see there are like three outliers. Okay, and here 60, that's the point. Here 60 is an outlier, but here 60 is not an outlier. Agree? Because we have more data in the actor, but actress, anything greater than 45 they are considering it outliers. Fine, because these are treated as exceptional, because nobody acts at that like that age compared in the actress section. Agree? So I'm able to understand these things. Fine. So any other observations, guys, you are able to you can make by comparing these two graphs? Yeah, median of median of actor is also greater than median of actress. Okay, or if I take it as median of median of what, median of males is greater than median of female. Okay, that means what, they are, okay, looks like they're having more life. I mean more life in the sense like acting life, because the median is bit higher. That means maximum values, it is having maximum number of values below here and also above here. That means it's having more acting career, obviously. Fine. So any other observation can you make from the from these guys? See, the median is not in the middle of this box. Agree? It is not like this in the middle. It is not like that. It is slowly shifted towards the lower side. That means what, more numbers are packed over here. Agree? That means what, that means what, there are actors whose age are between 22, let's say, and somewhere around 33, 22 around 33. The density is high, the numbers are high. That means more and more heroines are coming up from this age. Okay, and after that the spread the spread is slowly increasing. You can see the gap, the upper box, this space is higher than this lower space. That means after median, after let's say 33, the spread is increasing. That means you don't find actress like very packed. That means you don't see 33, 34 like that. Okay, you are seeing 30, 33, that you can find something 35, okay, 38, okay, like that till 40, okay, 48 or something like that. The spread is not closely packed, but here below this it is very packed. Like you can have 22, 23, okay, very closely packed ages of the actress. Getting? So is this clear, guys? Do you think is it's helpful box plot? Are you able to infer something just by looking at the graph itself? Because see, you also don't know what is the data. I also don't know what is the data this is built upon. But at least we are able to bring out some insights, right? We are able to get a picture. Fine. What is the range of the data I am dealing with? Agree? So if I just want to come up with the column, what column, so I can start with, okay, this actress column, this actress column might be a column. Okay, if I want to guess, that should start around some 22. Okay, and there are the median is around what, median is around 33. Okay, I will write 33 over here. Okay, and overall values if I consider it as 100, fine, 100, fine. So there should be 100 values, and the maximum value is around some 45. Okay, so but as you can see, median is shifting towards this lower bound. That means more values are packed over here. That means what, over here in this, here should be 50 values. Okay, here there should be 50 values, here also there should be 50 values. Okay, but the values are very much closer to over here. That means what, 23, 24, 25, 25, again there could be 25. Okay, something like that. Fine here, but the values are slightly dispersed over here. Okay, it could be some 37, 39, okay, some 43, okay, like that, again some 40. Fine. So the value, the median is slightly closer to the lower bound. Okay, so to this, the lower bound 22, wherever it is there, right? So it will be a bit closer to that. Fine, guys, did you get this?
Yes, sir.
Okay, fine. So after that, I'll just show you one example. So if you see here, fine. So this is a manufacturer origin of cars. In cars, we have different types of cars, right? So if you're aware, we have hybrid, SUV, sedan, okay, sports, truck, wagon. Okay. So for example, you have Mahindra SUV, right? Nexon SUV, all this. Okay. Or in sedan, you have Benz, okay, or Polo, Vento, okay, some large cars, sports cars. You have truck, wagon, okay. And three countries are originating, like Asia, Europe, USA. Fine. And type and the invoice, that means the price, okay, of the cars. So by just looking at this, you can make different observations. Fine. So for hybrid, there is not much data available. For SUV, say for SUV, if you see this graph, okay, what is this blue color? Blue color is Asia. Okay, for Asia, you're having one outlier. Fine. That means there is one person, okay, who has bought the vehicle with high price. Okay, we don't know why did they sell to that price, but you can see that is an outlier. Okay, but the maximum price, but the range of cars are costing high in what, this orange color, Europe. Okay, in Europe the range is high. You can see this graph when compared to only these three. Okay, these three are for the SUV. This is larger, right? So that means it is somewhere around 50, so it will take a 75. Okay, 70. Fine. So this, in Europe the cars are a little bit costlier. Okay, because the maximum value is bit higher. Okay, see, and just by looking at this, what is the car and what is the country which is selling the highest car, highest price car? What is the brand of that car and which country is selling, guys?
Sports car, Europe.
Correct. So in the sports section, you can see this orange color. So that is this color. Okay. But this is also, even if you consider outlier also, this is the guy, but we are not sure why this is an outlier. Okay. Might be this particular price. Okay. See, you can guess, right? So this particular price, usually the sports car are around this range. Okay. But you can see something extremely high. Fine. So what could be the reason, guys? This could be design on special demand. Agree? Sports car, let's say this is going for some racing, okay, F1 race sort of thing, and some businessman or due to some business requirement, they have designed specifically in the sports section, and obviously they should sell us very high price. Fine. So that's why this is standing over here as an outlier. But again, as I said, because of outlier, this is a not a useful point. Here it is obviously telling us a very useful point, saying that okay, this has prepared, okay, this has created on a special demand purpose. Okay, that's why its price is very, very high. Okay, that one info you can obviously make. Fine. And in sedan, you can see there are like three outliers. Okay, obviously it makes sense, right? Because sedan class, okay, like all the celebrities and high class people, they use sedan cars. Okay, Benz, Audi, okay, and Porsche, okay, Lamborghini. Okay, these cars like usually come under sedan class. And as you can see, there's few outliers over here. Okay, few outliers over here. Why? So many requirements will be there for a special on demand. They will generate, okay, or prepare some cars. Fine. On demand they will sell some cars due to some additional fittings. Or for example, if you go to Arab, fine, they like gold, right? They go for gold coating. Fine. Even for the normal car also. Fine. So that's why if the usual car is this much, the maximum price, if you put for some additional fittings and gold layer, it will go to way high price. Okay, this is the outlier. Agree? And as you can see, vegan cars are okay, vegan, and also clearly you can see which country is not selling any trucks, guys.
Europe.
Correct. So okay, so Europe, it is not selling any trucks. Okay, fine. So like that you can make multiple, okay, observations from here. Fine. So that's all, guys. So that's all I would like to share about BoxPlot. Fine. I hope you understood BoxPlot. I hope you understood different concept of BoxPlot and how you can find out outliers, etc. Yes. So fine. Are you going to college, Meghana Session?
No.
No. Okay. So can we can we continue for an 5 minutes? I would like to give an overview.
Okay, sir.
Okay. Okay, fine. So this no, till BoxPlot it is done actually. Okay. So I hope you understood. Okay. So what all we discussed, we started with the percentile. We understood what is percentile. Then we understood quartile. Okay. Then we understood manually how to plot, and we understood the BoxPlot creation, each and every part like lower bound, everything we understood. Fine. So when I say I understood, that means you understood. Okay, not me understood. Okay. So if you do not understand, you can raise a question. Okay. So and also show you manually how you can plot. Fine. And also plot wise how you can plot. Okay. Normal plot, box plot. Fine. And then we understood the box plot is nothing but always remember 5 point summary. Okay, 5 point summary. Fine. Then we have seen how it will deal with the outliers. Fine. Just by looking at how what all you can infer, what is the distribution shape of the graph. Okay, clearly you can understand a few things. Okay, and outliers, etc., etc. Fine. So that's about the box plot, guys. Okay, so with this I could say we have completed level 1 of the stats. Okay, level 1 of the stats. Fine. So just to give a recap, guys, just to give a recap, because you will be getting, so obviously today you are not going to college, and tomorrow will be a Sunday, right? Again we'll be meeting on Monday. But take some time. Okay, take some time. As I said, stats is that type of concept. So where while in the class you will feel that you understood, but most of the times it again skips, vanishes from your mind. Okay, because these are a bit new concepts, right? So just try to revise it so that they will stay in your mind, okay, at the end of the course, because we have still so many days to cover the course, right? So that's why don't leave this, right? So if you just stop revising, so you will at least for stats, Python obviously you will understand, but just for stats from my own experience, because I personally studied stats at least 3 to 4 times. For the first time you will think you understood, second time you will know you did not understand, okay, third time again you will think okay you are understanding somewhat, fourth time you will get an idea. So like that, stats usually requires like multiple times to go through, right? But the main important thing is you should make notes, because if you don't study, make notes, right? So again you will not have patience again to start from scratch. Okay, even if you study by yourself, I don't think you will go through line by line as we are discussing in the class, right? So you will not have patience. Okay, so that's why start making notes. Okay, take some time over this weekend. Fine. So just give you an overview. So if you remember, fine. So if you remember, so we have successfully right? Reach to, I would say, level 1 of stats. Okay, and you can see that we have started with the differential statistics, inferential statistics. Agree? So did I share this did I share this with you guys, this
Yes, sir.
No, no, Santosh.
no?
Share, sir.
Huh, shared. Can someone confirm?
No.
I
Can you
remember,
please share it?
I think I shared it in the chat in the WhatsApp group, right? Fine. Anyway, if it's not shared, I will share again. Don't worry. Okay. Fine. So after that, we have seen inferential, differential. Fine. Then we understood what is the types of data: categorical, numerical, discrete. Agree? Then we came here, understood different levels of measurement: nominal, ordinal. Agree? Then we came over here. Then we try to understand central tendency, the main concepts of mean, median, mode, right, and range. Fine. And then we understood the frequency distribution table. Okay. Once we are done with this, then we understood frequency distribution, relative frequency, cumulative relative frequency. Fine, guys. And then we understood what is a skewness, what is a right skewness, what is symmetric, what is asymmetric, what is negative skewness, and what is the influence of mean and median on the skewness, where it will shift, why it will not shift, and how to fill the missing values. Fine. Then we understood the histograms. Fine. And then we understood the dispersion values. Agree? Standard deviation we understood. Variance we have discussed. Agree? Coefficient of variance. And also one important concept example we have seen, like why you should not blindly go with the mean, how you should go a bit deeper and understand what is the variance of the data, and then you can take a decision about which is better, where you are having consistency. And we also see what is population, what is sample, and why n minus 1 relate to the degrees of freedom we have seen. Agree? Then we have seen covariance, we have seen correlation. Agree, guys? And then we have seen what is a covariance, correlation, why correlation we need to study even though we are having covariance. What is the difference between the formula? How correlation is very important. What is the range of this? What are different types? Pearson, right? Pearson correlation. Agree? What does this mean? Okay, different types of correlation, practical examples. Agree? How you can code, and also wherever it is required, we have also seen the code, how to code for the correlation, how to code for the bar gram. Okay, how to code for the histogram, right? So how to code for the plots. Fine. I think we have seen yeah, and also we have seen the examples of right, how to calculate, yeah, how to see the mean influence on the outliers, and also the simple mean median, how you how you can pick up, right? And also I think we have also seen how you can clearly plot histogram, how you can clearly plot box plot, how you can clearly plot scatter plot. Fine. And today we have seen how you can plot the box plot. Okay, and then with the seaborn diagram. Fine. So then we have also seen what is the effect of this on the outlier part also, just by looking at how you can infer. Fine. So looks like, yeah, we are good with concepts, at least in the class. From my side, I have discussed what all things are required, and also I hope you also understood most of the concepts. Fine. So it's your job now, so try to revise this. Okay. Note down any questions. Okay, it's completely fine in stats. Even if you are city dot also, that's completely fine. Note down your questions wherever it is required. Okay, at least make sure that you are good with this level 1, because from Monday we are going to start level 2, where we are going to study about the probable distributions of the data, actual distributions of the data. Fine. So there actually it comes. Okay, the whole stats is actually based upon some distributions. Okay, different types of distributions we see. Okay, some probability distributions, normal distribution, standard normal distribution. Okay, from here we will go to the level 2. Okay, this will be slightly, okay, difficult, okay, or tough, I would say, to be honest. Okay, but I will make sure that it is as easy as possible. Fine. So don't miss a class, I'm saying, for the at least in level 2, right? So don't miss a class, because it will be completely difficult for you to follow, because even in the class, if you listen, if it is 100%, okay, you might get like 80%. Again, if you revise, you will get 100%. But if you miss a class, you, even if you think, okay, you will go through the class, but that will be really difficult. Fine. So don't do that, I would say. Fine. So yeah, so that's all from my end actually. So just I would like to, just for the correlation part, right? So you can also, if I have not shown, okay, so fine. So I will using for correlation, I think I have shown you how you can do it on the using this formula, right? So NP on area, this graph. Okay, you can also plot this graph. Actually, you can also plot this graph, okay, using Seaborn. Okay, using Seaborn. Okay, you can plot the correlation graph. Okay, that thing, one thing I'll show you using the when we are studying the seaborn. Okay, so just one plot I would like to show you. Okay, apart from that theory part, code part, and visualizations part, I think I'm good. Fine. So just want to give you a quick overview. Fine. So that's from my end, guys. So any concerns, any questions, any suggestion, guys? Are we good, or anything you want to share about statistics specifically? Like how are you feeling? Like are you feeling it's as of now it's tough or new, or it's easy going? So uh, can you just share your thoughts?
Yeah, it's good, Santosh. Just we need to practice.
Okay.
Yes,
Okay, fine. So yeah, so that's all from my end. Okay, so we can meet on the Monday. Fine. So if that, just before going, right, so if at all you guys are very much, just in case if you're interested to ISLR. Okay, yeah, so we have this book, guys, called as Introduction to Statistical Learning. Fine. So you can ISLR statistics. Fine, you can just I'm putting in the chat, so I don't know whether you can, yeah, you can copy this. Okay, so this book, so it is one of the famous book in the data science world. So where it will give you introduction to statistical learning. It will teach you like in simplest way. So if you're interested and if you want to go to next level, so you can study this book. Okay, or else you can, okay, go to the revisit revisit the class and try to make some notes. Okay, fine, guys. So that's all from my end. Hope we are good. Fine. So let's meet on Monday. Wait one second. Monday everyone is joining, right? Or let me know before only. Okay, so if you are on Tuesday, we have festival. Fine. So are you guys joining on Monday and Tuesday?
you Dasara holidays, sir.
Hmm? You want Dasra holidays? This is not college. I can give, no problem, but your course will get delay. Okay.
1
Just a
week,
second.
sir. We will practice for practice.
Okay. No, I'm asking, are you going to join on Monday?
No, sir.
No. Okay. Why? Festival is on Tuesday, right?
Dasara is on Monday only.
Oh, okay. So Tuesday, you guys will be joining on Tuesday.
Yeah, Santosh.
Yes, sir.
Okay. Fine. So okay, fine. I will let me know in the chat. We'll discuss. Okay. Fine, guys. Chalo. Thanks. Thanks for joining.